See this rocking over here? That is not ideal. We might have a problem. Happy New Year! My body is not ready. 1 second. Not a beer this time. Eventually you do need water in your life. Ugh. Anyway guys, welcome back to Make and Break It. Happy New Year's! So behind me on our CR-10 is a calibration model. So this calibration model might seem familiar to you guys. It's what we used last time to help with identifying some of our issues, which major issue was strain. But it also can work to help identify our next major issue, which is warping. So this is hopefully going to be a shorter video, shorter tips and tricks on warping, what it is, and how to go deal with it. So, what is print warping? Print warping is a pretty simple concept. Print warping is a pretty simple concept, and it's essentially where the print, due to thermal forces most of the time, will actually just bend and twist itself around. And this happens because different parts of the print are at different temperature levels, and as things go from hot to cold, they tend to contract and get smaller. And that'll twist everything around if you don't combat it correctly. Ooh, yeah. So getting over that New Year's. It's not necessarily the end of the world. However, it can cause prints to fail. It can also make prints just look bad. If you get warping, none of the bottom edges are going to look correctly. They're going to be all turned in and everything. It's really not a good look if you're trying to print like a final function form or even a mold piece to go create. So it's something you do want to address once you have the rest of the pieces and settings of your printer ready to go. But how do you address that? Well, combating it is, the concept's pretty simple. You want to control the temperatures in your print such that they're fairly consistent as much as possible, and that really reduces the contraction forces and the thermal forces on the print as it's going along. And that can be done in many ways. One of the first ways to do it is to use a heated bed. Now, most printers nowadays are sold with a heated bed. It's not really a concern to get one. Even my $180 printer on my desk has a heated bed that I might have to go fix. All these CR-10s and everything that's relatively equivalent, all of these sorts of gantry style printers, almost all of them have heated beds nowadays. It used to not be so, and you don't necessarily need a heated bed to print PLA, but all of them nowadays have it because it's a really cheap and easy thing to make printing a lot easier. The other things you want to do is you want to recheck your setup. Check your level. Check your bed adhesion materials. If you're using glue, if we're using glue sticks or something like that, do check your glue is still applied properly. Maybe go ahead, wash it, and reapply a new layer down there if you're having too many bed adhesion problems. And something that seems kind of weird to say, but go ahead and clean your printer. So one of the things that could be causing troubles with bed adhesion, and even if you have good bed adhesion, it could be exacerbating your warping issues, could be dust and a layer of material underneath your plastic on the print bed, and so that can cause it to slide. It's essentially like printing on little small tiny marbles. So if you don't have a good clean print bed, go ahead and give it a nice really good wash, and then apply whatever adhesives and whatever else you want on there. The next set is some slicer settings that pretty much any slicer out there will do it. It's in different places, but you add some build platform addition. There's 3 types of build platform additions, and they all serve mostly the same purpose, and they use increasing amounts of material. So the least material intensive is a skirt, and that is essentially, it traces the outline of your part in a couple extrusion widths around your entire part. And the idea is it provides a little bit of block from air intrusion underneath your print. and just a little bit of thermal mass to maintain the heat in the part. Because usually the problem with lifting and warping like this is your print bed is not maintaining the material hot enough to stick, and so it tends to lift as the thermal forces get applied to it. The next one runs the same way, but also helps directly with adhesion. It's called a brim, and it puts a single or maybe multiple layers, depending on how you set it up in your slicer. It puts layers directly attached to the outside of your part. So for example, if we were using a brim on this one, it would put layers attached directly to the outside of our part here. It serves to create a bigger contact patch for your piece, as well as preventing air intrusion under your main pieces, and then they're usually pretty easy to snap off at the end. The final piece is the one I use typically, even though we're still having these issues. The final piece that I would suggest using is a raft. And a raft is essentially something that sits under and around your piece, right? That provides a big thermal mass for you. It also will build a couple layers up underneath it so that your piece hopefully doesn't warp even if the raft moves a little bit. And why I like to use it a bunch is it can address maybe some imperfections in your print setup. So you don't necessarily have to be perfectly level or perfectly heated or have a perfectly flat build plate in order to make everything work and look good, because you're building your own essentially secondary build plate underneath your print every time you print it. And you get a consistent base layer, you get consistent adhesion, and they're usually not that hard to pull off your print. So I tend to suggest using rafts, but they do use a lot more material, and they do typically add more time to your prints than either of the other two options. The other two options are maybe another 10 minutes to your print. A raft can add several hours to your print, depending on how large of a raft you need to build. And the final section of material or a section of things that you need to adjust is your actual bed temperatures and possibly your fan speeds. So whether your bed is too cold, like might happen in ABS warping, or too hot, like was probably happened here in PLA warping, adjusting your heated bed temperatures to be better for that material definitely can improve that material's warping problems. That's probably what's happening here, because we were trying to, on our old glass bed, we were trying to address bed adhesion, which is almost always because the material is just too cold, or the bed is too cold. It doesn't really matter what material you're talking about. We're trying to test bed adhesion, and we ended up with a bed temperature of 70 degrees C. This is on the very, very high end of what you would even consider doing for PLA, and it's actually generally not what I would recommend if you're printing this in any normal situation. We're in a colder garage workshop area, so it seemed like the right thing at the time, but now we're seeing a bunch of warping issues, so we might have gone too far. This is also comes into play if you're using like adhesives and things like that. You can usually get away with a lower bed temperatures for PLA in order to get the same amount of adhesion. However, you do not want to do that if you're doing ABS. If we're printing like this in ABS, it's because our bed temperatures are too cold typically. So that's because then the material isn't staying heated and malleable like the rest of ABS, the rest of the print is, and it's starting to lift. So typically if you're having ABS lifting issues, it's because you need to work on getting your temperatures up. The final sort of tweak that you can adjust before looking at major things like getting different filaments, which I'm not too worried about here with mine, is your fan speeds. So in materials that are getting printed too cold, or that are becoming too cold while they're being printed, fan speed can be a big factor. And what it essentially does is every 3D printer has a fan that's, I think it's this one here on this side, that sits there and blows air over the filament that was extruded, so it cools in place and stays in place for the next print layer to go over it. The problem is if the air is too cold that it's blowing, or it's blowing too much air over it, it can actually overcool it and cause a bunch of stresses in the part. That's not really a problem with PLA necessarily, but ABS and nylons and a bunch of the other materials that have thermal warping issues, that can be a problem, and you might want to adjust down your, you might want to reduce your fan speeds for higher levels of your part so it doesn't create that thermal warping issue. So those are the major factors, and we're going to go try to apply them here. So this model here was printed with our pre-stringing profile, in fact. So there's still some stringing issues. So what we're going to do is we're going to go into our slicer, pull this model out, and re-slice it with our new updated slicer with a reduced bed temperature. Because this bed has a material applied to it that should hold prints better than straight glass, we think reducing the bed temperature here will reduce our warpage of our bases without causing us to get back into adhesion problems. Alright, well, you can see behind me the printer is stopped and this thing has not finished yet. That's because we're already seeing warping in about the same places we were seeing it before. So I shot some B-roll, hopefully you guys are seeing that now, and didn't see a whole lot of reason to continue the print. So what we're gonna do to check our assumptions here is we're actually gonna go in and reprint this model the same way, but with one difference on the setup. So on the setup, what we're gonna do is we're gonna go into the control module over here. We're gonna go in and preheat the bed to 60 degrees C, or right around there. And we're gonna let that sit for at least 10 minutes. The thinking here is that this is a decently thick piece of glass, I think. Pretty sure that's glass. And we want to make sure that the bed temperature is what we think it is. So when we set 60 degrees C, that doesn't mean that every piece of this surface is in fact 60 degrees C. What it actually means is that the thermocouple that's about here, center line, underneath the build plate, is 60 degrees C. So if we give it time to heat up, that should heat up the build plate to something more of a uniform temperature. And hopefully that helps us out here, because I know we've had adhesion problems before, but not uniformly. And we haven't had this lifting problem uniformly either. So I am interested to see if that solves it. If that doesn't, I think we're going to bust out our old stringing models and do a kind of a build plate test here and see if it's in fact the way our heating element heats the build plate. So we'll do all that stuff, set it up again, and come back to you guys once we have results. Joey, I need some emotional support. This has not gone well. Joey the adventure dog has become Joey the emotional comfort dog here. This has not gone well. So we're about 12 hours after my last set of prints over here. Got 2, 3, 4 different prints back over here of various levels of warpage. And they were not super successful. So I printed these at sort of original settings here. This thing's pretty messed up. We saw that in the opening. I then went and printed this one at a lower bed temperature, and it's still warped, not as bad. It still has some warpage here at this front corner where all the worst warpage has been on every one of these models. Might be a model thing or where it's placed on the print bed. I then let the print bed stay heated and printed this one, and the warpage is pretty much the same as the one at the lower heated bed temperature of 60 over 70, which is what we'd been printing previously. I then went and printed this one, and I printed this one at a bed temperature of 60 and an extruder's temperature of 195 degrees C. And this one warped worse and in more directions than our original one. So what that says to me is that it was actually not really attached to the bed very well, and at the 195, so you do need the higher extrusion temperatures, at least lower levels, in order to get everything to stick to the bed. So I wanted to check out and make sure that I wasn't just printing on a cold spot on the bed, because these beds do not necessarily all heat uniformly, especially on the budget end of the spectrum for 3D printers. So I oriented an array of my stringing cubes set up and was going to print them on the print bed, but as you can see, it has gone poorly. So I watched it start, and it seemed like it was starting just fine, and I left and had an evening with the boss babe, and I came back to this. Well, not even this. All of these pieces were glommed on up here and under here and around here. So much so they actually pulled the silicone off of the extruder. And I've actually pulled apart the fan shroud housing. You see all this? We'll get some B-roll for you guys if you can't. You see all of this plastic is just glommed up on the extruder on the hot end. So what that says to me is this print failed essentially immediately after I walked away, and then I come back 10 hours later into a 12-ish hour print, and all the plastic is glommed on the extruder. This is what can happen if you get something wrong early in the print and don't catch it. I usually check prints a lot earlier than this to make sure everything's working, but I didn't this time, so that's my bad, apparently. But we can't continue working on that while this is here, because this is essentially just a terrible mess of plastic over our hot end, and we shouldn't be printing like that. So I'm gonna have to get in here and disassemble this thing even more and try and get all this plastic off of our 3D printer. Awesome. So hot ends disassembled, reassembled, mostly cleanish. Hopefully I put everything back together right. Don't forget, when you're doing something like this, if you're ever disassembling the hot end or disassembling your bed plate, you do need to re-zero. Because the zeros on 3D printers, you're not leveling to gravity. You're not leveling to level. You're leveling to relatively level between the hot end up here and your bed plate down here. So if you ever do anything that could jar one of those, like disassembling the hot end, you do need to reset your level even if you haven't printed anything since the last time you set your level. So don't forget to do that. And we're going to try a different print. So apparently the way I sliced that print in there was not correct, which is a little annoying, but what can you do? So what we're going to do now is I had loaded up another print on here which has some temperature changes. So one of the ways you can handle needing higher temperatures for lower layers and hopefully lower temperatures for upper layers to reduce the amount of contraction is you can go in most your slicers and update your temperature control to give it like certain temperatures for certain different layers and beyond. So what I did is for the first 3 or 4 layers, for my hot end, I set the temperature control at 205 degrees, which is where we're seeing we need to go for adhesion to happen, for bed plate adhesion to be a thing. And then what I did is after those layers, I set the temperature for extrusion at 195. So 195, if we're looking at the actual surface condition, is actually a better temperature in a lot of ways than some of these other ones. It gives us maybe a slightly cleaner surface condition. So it is a better extrusion temperature. It just doesn't stick to our bed plate very well. So that's why we're gonna transition back down to 195. Hopefully we're getting a little bit better surface condition. We're also hopefully gonna get less contraction, less thermal contraction, which will maybe get rid of our warping issues. Stop this thing here before we lose anything. Stop print. And then pull this over here so that it doesn't stick to all of our pieces. So we have, this is our array here, and this was supposed to be 7 each of our towers, our stringing towers. This was a test I showed earlier. See the video that's up here, wherever it is. That one, everything stuck fine. There was a little curling on these front 2 sections, but it was only 5 up through the middle. And everything else seemed to be okay. As you can see here when we're printing this, this is not good. This is actually pretty bad. There might be one... We didn't even get to the point where the blocks are building up, which is astounding to me. But as we look down here, I've been looking at them, and there might be one, like these 2 ones right here in the center of the build plate might be the only ones that don't show signs of significant warpage. Like these, like this area, these 2 to 3 are the only ones that are really stuck to the build plate. As you can see, that one moves. That one's basically stuck. That one's basically moving. This one's mostly, oh, that one was mostly free. I've just barely touched it and it broke away. Obviously, these 3 are completely broken away. Back here, you saw some video earlier, this one's broken away free. That one's still stuck on, but it's got significant warpage over here, and it's not, like, there, it's free. So it was not long for this world. This one is already free. This one, basically free. This one stuck pretty good. This one was stuck okay. This one, not very good. And that one, not awesome. So, we found that our warping is bad all around, which was not the case when we previously tested this, and our bed adhesion is barely acceptable, which is actually kind of what you'd expect. If you have huge amounts of warping everywhere, your bed adhesion is also not going to be very good, which is the whole point of this print bed. So I'm wondering if so I was wondering if it might be the print bed, and I kept the old calibration model just for reference, and just because engineers keep desk toys. So I wanted to pull that out and compare it to the calibration models I had been printing previously and see if they were different, because the old calibration model was printed on the glass print bed with some glue, I believe, on it. It did not have curling issues, I didn't remember, so I wanted to go look at it. And there it is. So let me sit down here. So this white one over here was our original calibration model that we printed. And if we get in here close, you can see that that bottom corner is actually pretty good. Maybe a little bit of warpage right here at the corner, but everything looks good. It looks straight on the model. No real warpage anywhere, right? And we know this is our old calibration model because of the excessive amount of stringing, like, everywhere. There's stringing all over the places in between the parts, which kind of matches how this one was in terms of stringing. There's stringing all over the place in between parts, but you'll notice that edge is significantly more. We'll get down here and you can kind of see that edge is significantly more lifted than this one maybe is. And So that's the warping that we're seeing. That's a direct warping here. So everything here is lifting and contracting in. Where this one you can see, go put this on this side so you get a good edge comparison. This one's very straight, comparatively speaking. So something's going on here. We've changed something, or something has changed between these two prints. Because this one was printed with the same exact... I printed off the same G-code file as this one. But obviously the warpage is quite different, and the temperature, if anything, is better for printing. So something is going different. So I went looking at our video, and this one, as well as our old stringing models, were printed on this build plate with glue applied to it. I had subsequently then changed to working with this build plate because I liked the idea of not having to deal with the glue application a bunch. And theoretically, this build plate doesn't need a glue application or any sort of adhesive application to fix your issues. But as we've just seen with all of this crap, adhesion's not great on this build plate. So we're going to see if a build plate change is in order. So what we're actually going to do is pull this off. And put our old glass plate on, re-level everything, apply some glue, and print these models, which were fine on this build plate, on this one with glue, and see what happens. Would you look at that? Not a single sign of lifting, and this thing's been cold for hours. Look at that. Well, it took many days and a lot of printing to figure out that the new build plate is worse than the old build plate. This happens sometimes when you're working on 3D printers and just other parts like that. Sometimes you make a change and you think the change will be good, and it turns out the change made everything worse. So I got to deal with this a lot also in my previous employment. So nice to see some things don't actually change. But we figured it out. So we got our piece off here, and there's essentially no warping on it. So what we've found is, and actually there is no warping. I don't see any warping here at all. So what we found is that our newer settings that we thought were supposed to be good were actually good. It was our build plate that couldn't keep up. So that's some information. That's a little sad that Creality build plate with the adhesive sticker, whatever it is on it, isn't as good as a regular glass plate with glue on it. But I mean, I didn't necessarily know that when I purchased it, unfortunately. I probably should have had lower expectations. But anyway, we solved our warping problem. So now everything seems to stick pretty good, and I can start back here printing the things I actually want to print on this printer. We've got some tools coming up for an upcoming video, so that's exciting. We can start printing PLA on this one and start printing cool new stuff on our Raise 3D. I got some cool flexible filaments that I'm going to test out. So anyway, thanks for watching, everyone. Hopefully this was informative, both on things that cause warping and how to go troubleshoot it, especially when things don't work out properly. If you liked this video, go ahead and hit that like button. If you disliked it, go ahead and hit dislike. It doesn't hurt my feelings, lets me know what videos work and what don't. If you like what we're doing in this channel, we have motorsports builds, cars, motorcycles, an interesting build I think that's coming up if I can work out the logistics. We also do 3D printing and help you apply what is relatively inexpensive and new technology into your home garage. Check out the other videos on our channel and hit that subscribe button. So until next time, guys, my name's Andrew. This is Make It and Break It. We'll catch you later.